Okay, so what you guys just saw a second ago was how to create the equation of a quadratic using just a vertex and a point, right? So what I'm going to show you now is how to create the equation of a quadratic using X-intercepts and a point. So before, when we were using a vertex and a point, we used vertex form of a quadratic, right? Now we're using x-intercepts and a point. So we're going to use intercept form of a quadratic. Intercept form of a quadratic is y equals a. Guess what we're going to be solving for in a second? A, just like before. Y equals a, except now you have x minus p times x minus q. This is the form that you get when you factor, right? And it finds the roots. So here you go. If you're given the roots and you're given a point, it's the same idea. Okay? So here's my roots. 4, 0, and 24, 0. Those are my roots. Here's my random point. My random point is at 0, 9.6. So real quick, when you look at this, what's the value of x and y? What's the value of y? 9.6. That's your y value. What's the value of x? 0. Guys, just like before, there's your x, there's your y. So let's go ahead and write this out as we go through. 9.6 equals a times x is 0. 0 minus something. 0 minus something. Where are the p and the q coming from? The roots, right? So p, q. Okay, minus 4 minus 24. Solve for a. Same thing. Solve for a. So 0 minus 4, that's negative 4. 0 minus 24, that's negative 24. Negative 4 times negative 24. So 9.6 equals a times negative 4 times negative 24 is 96. So let me write that in a different way. 9.6 equals 96a. Divide by 9.6, a equals 0.1. What am I going to do with that? I'm going to rewrite this equation with that a. And this p and that q. So here's my final answer. Y equals 0.1 times x minus 4 times x minus 24. It's the same exact concept, except now we're not doing a vertex and a point. We're doing x-intercepts and a point. So we use x-intercept form. Okay?
Yes.
All right. Cool beans.